My dear students, Assalamu alaikum. I think you all are fine. I am ABA Moinul Islam, Associate Professor, Department of Mathematics, Rajagutra Model College. Today I will discuss on a chapter of second paper, and this chapter is exercise 9B, and the name of this chapter is acceleration. This is my second lecture on this chapter. Today we will discuss two very important maths. First of all, example number 4. So we want to go for example number 4. Here the question is, show that for a particle moving with uniform acceleration f in a straight line, just f is equal to atto. It is required to prove that s is equal to atto. And here also is given where s is the space described in t second and s prime during the next t prime second. Okay, that means here given a particle is moving, suppose from point A, and at first we consider its initial velocity u. For the distance AB it moves, the whole distance the particle moves with uniform acceleration f. This is f, and given at first t second it covers distance s, and suppose it reaches at point B, and at last t prime second it covers distance s prime. This is given. So okay, at first we describe the figure. Let initial velocity of the particle be u, and its acceleration is f. Again let okay, this is given, that is the particle covers distance s in first t second and covers distance s prime in last t prime second. ঠিক আছে? So okay, so now first formula, now s is equal to first formula, the particle covers distance in time t with acceleration f. So here we can write s is equal to ut. Ut means u into t. Here f is acceleration, so plus half of ft square. You can see that in proof we need s by t. Okay, s by t and s prime by t prime. So from here, if we divide both sides by t, then we get s by t is equal to u plus half of ft. This is equation of 1. Again, you can see that here u is unknown. Okay, so here u is unknown. So therefore, if we apply formula for whole distance, that is for s plus s prime, then total required time is t plus t prime. So now we can write the particle covers s plus s prime distance in time t plus t prime, so that From second formula we can write s plus s prime is equal to, that is s is equal to ut. Here initial velocity is u, t means t plus t prime, ut plus half of ft square, this is f, and t square means t plus t prime whole square. A is equal to ut plus half of ft square. Okay. Now if we subtract this equation, that is s, if we subtract this s from here, then we get s prime, and therefore we will get s prime by t prime. So now we subtract this equation from this last equation, then we get s plus s prime minus s is equal to, at right side, u into t plus t prime plus half into f into t plus t prime whole square, and minus ut minus half of ft square, like this. Or at left side we get s prime is equal to, at right side u common from first and third term, from first and third term u common, then we get t plus t prime minus t, and from here half of f common. So if we apply formula here, so we can write t square plus twice t prime plus t prime whole square, and here minus half of f common, then we get t square. So this t square cancelled, here also t cancelled, so we get s prime is equal to ut prime and plus half of f. Here t prime is common, then we get twice t plus t prime. Okay. Now if we divide both sides by t prime, then we get at right side u plus half of f into twice t plus t prime. This is equation number 2. Now in proof we can see that s prime by t prime and then minus s by t. So now we subtract equation 1 from equation 2, then we get at first s prime by t prime. So just from equation 2 we minus equation 1, then we get s prime by t prime is minus s by t is equal to, right side, u plus half of f into twice t plus t prime, and minus, here equation 1 is minus u and minus half of ft. Okay. Then at right side, here u and u cancelled, we take common half of a, then we get twice t plus t prime and minus t. So here we get f by 2 into t plus t prime. That's all. That is, or f is equal to, here f is equal to, we can write 2 into s prime by t prime minus s by t, and divided by t plus t prime. So this is proved. Okay, proved. Example number 4. It's a very important chapter. Just I want to hold sometimes for you so that you can take a screenshot. Okay, just I hold sometimes for taking your screenshot, so you can take a screenshot. Now I go for next math. It is example number 5, and it's also very important. Okay, I think you take a screenshot. Page number 2. Now we go for example number 5. It's also a very important math. Here question is, if v1, v2, v3 be the average velocities in 3 successive intervals of times t1, t2, t3 respectively of a particle moving on a straight line with uniform acceleration, then show that this. Okay. So at first we draw the figure. There are 3 parts because there are 3 average velocities are given. First part is A to suppose B, second part B to C, and third part suppose C to D. The average velocity for AB is suppose V1, then here is V2, and at last part the average velocity is V3. Now we consider initial velocity at point A is U, at point B here acceleration is F, average velocity is 3, here given uniform acceleration, so let acceleration is F, so its velocity will be increased. So at point B suppose it is U1, at point C velocity is U2, and at point D we consider velocity be U3. Okay, and time at the part AB it is given time t1, here time t2, and at last part time t3. So again we want to see here given v1, v2, v3 be the average velocities in 3 successive intervals of time t1, t2, t3. So now we can write let given, at first we want to write given at time t1, t2, t3 average velocity of the particle. Come on, at time t1, t2, t3 average velocity of the particle are v1, v2 and v3 respectively. Okay, now let initial velocity. Okay, at first we want to write acceleration. Let acceleration of the particle, let acceleration of the particle here is particle, so acceleration of the particle be f, and initial velocity of it be u. Okay, initial velocity u, we consider u, and acceleration is f. After time t1, t2 and t3, let the velocity of the particle be u1, u2 and u3 respectively. So therefore u1 is equal to, at first we will find out these unknown values u1, u2, u3, and therefore we will write the formula of average velocities, that is v1 is equal to u plus u1 by 2, v2 means u1 plus u2 by 2, and at last v3 u2 by u3 by 2. So at first we can write u is equal to u plus, that is formula is v is equal to u plus ft. Okay, v means u1 is equal to u means u plus ft, that is ft1. Similarly, u2 is equal to u1 plus ft2. If we put this value of u1, then we get u plus ft1 plus ft2. And at last u3 is equal to, here you can see that u3 is equal to, here initial velocity is u2, so we can write u2 plus ft3. So if we put this value of u2, then we get u plus ft1 plus ft2 plus ft3. So we find out these three values. Again, we know average velocity is equal to initial velocity plus final velocity by 2. So we can write v1 is equal to u plus u1 by 2, v2 is equal to u1 plus u2 by 2, and v3 is equal to u2 plus u3 by 2. Now the left hand side of the proof is v1 minus v2 by v2 minus v3. Now we find out this value, and finally we will get the value is this. Okay, so now we can write v1 minus v2 divided by v2 minus v3 is equal to, now putting these values, we can write v1 means u plus u1 by 2 minus v2 means u1 plus u2 by 2. Here again v2, that means u1 plus u2 by 2 and minus u2 plus u3 by 2 is equal to, here 2 is LCM is 2, so we can write u plus u1 minus u1 minus u2 divided by u1 plus u2 minus u2 minus u3 divided by 2. Here u1 cancel, and here u2 cancel, and here also 2 cancel. Okay, 2 also cancel, so then we get u minus u2 divided by u1 minus u3. Okay, then we put these values, that is at first u is okay, u minus u2. Earlier we find out these all values u1 u2 u3, so at first you can say u2. What is u2? u2 means this thing, so we can add minus u minus ft1 minus ft2 divided by u1. This is u1, u plus ft1, and then minus, so therefore sign will be changed, u3. This is u3, but sign will be changed, so we can write minus u minus ft1 minus ft2 and at last minus ft3. Okay, so you can see that ft1 u cancelled here, and here u and u cancelled. So if we take common minus f, then here we get t1 plus t2. Okay, and here if we take common minus f, then we get t2 plus t3. So minus f cancelled, so finally we get t1 plus t2, and here t2 plus t3, and you can see that at right side is at right side here t1 plus t2 by t2 plus t3. So finally we get this, so proved. So thank you very much, my dear students. Now I want to hold some moments so that you can take a screenshot. Okay, please take a screenshot, then you can take a screenshot now. This is different method from your book. I think this is easier, you can follow this. Okay, I think you take a screenshot of this page. So okay, my dear students, we solved today two very important maths. So inshallah next class we also solve some another problems. So no more today. Thank you very much. Be safe and be well. Thank you.